Welcome back to the .NET Way. You're watching episode 13 of our .NET Core interview series. Up until now, we've talked a lot about writing and building applications. But today, we are discussing something that becomes critical after deployment: logging and monitoring. Once your app is live, how do you know what it's actually doing? Joining us to share her real-world strategies for tracking issues and performance in production is our software architecture expert, Arohi. Welcome back.
Absolutely. And in my experience, logging is the only thing that can save you when your application crashes and users start reporting issues.
Exactly. So let's start with the basics. Arohi, what role does logging actually play once an application is live in production?
It is absolutely crucial for detecting issues, troubleshooting bugs, and monitoring overall application health. When a user reports a bug, we can't attach a Visual Studio debugger to the production server. Logs help us track errors, understand user behavioral patterns, and get total visibility into what's happening behind the scenes.
Out of the box, .NET provides its own logging, but there are many third-party options. Which libraries do you typically use?
I've used NLog, the built-in Microsoft extensions logging, and Serilog. But my absolute go-to for modern enterprise apps is Serilog. I prefer it primarily because of its fantastic support for structured logging, its massive library of sinks, which are basically destinations where logs are sent, and how effortlessly it integrates into the ASP.NET Core pipeline.
Could you walk us through how you would actually set up Serilog in a standard .NET Core project?
Absolutely. If you look at the code snippet on the screen, you'll see how clean the setup is. Instead of scattering configuration everywhere, I set up the logger configuration right at the application's entry point in the program file. I define where the logs should be written. For example, writing to the console for local debugging and writing to a rolling text file that creates a new file every single day. Once that configuration is built, I simply tell the host builder to use Serilog as the default logging provider. It takes less than 5 lines of code.
You mentioned structured logging a moment ago. What exactly is that, and why is it better than traditional logging?
Traditional logging just spits out a flat string of text, like user John failed to log in. That is very hard for a machine to search through. Structured logging, as shown on screen, stores logs as key value pairs behind the scenes. So instead of a flat sentence, the log data is saved in a JSON-like format. This allows us to easily query, filter, and analyze the logs in dashboard tools like Seq or Elasticsearch. We can instantly filter logs to show every action performed by a specific user ID, without having to write complex text search expressions.
That makes searching much easier. Now, when writing logs, how do you decide what level of log to use?
It's all about filtering out the noise. The common levels range from least severe to most severe. We use trace and debug for highly detailed development information that we usually hide in production. We use information to track the normal flow of the app, like a successful checkout. Warning is for something unusual but not fatal. Error is for actual exceptions where a feature failed. And finally, critical is reserved for when the entire system is crashing. I strictly log only what's needed at each level to ensure our production logs don't become overwhelming.
How do you handle logging in different parts of the architecture, like custom middleware or background tasks? Do you just inject loggers everywhere?
Yes, the beauty of .NET Core's dependency injection is that I can inject the generic ILogger interface into standard services, controllers, hosted services, and middleware. However, for background tasks, there is one crucial detail. Since background services run independently, I always ensure that the logging system is properly flushed using log.close and flush before the application shuts down. If the app crashes, we want to make sure those final critical error logs make it to the file or database before the process dies.
Once the logs are written, how do you actually monitor them in real time? What tools do you prefer?
It depends on the environment. For local development, I absolutely love using Seq. It provides a beautiful, searchable local dashboard. When we move to production in Azure, I rely heavily on application insights. If we are using a Kubernetes or microservices environment, my team usually sets up Grafana paired with Loki. These tools don't just show text, they provide visual dashboards, generate alerts, and allow us to write complex queries to find exactly what went wrong in milliseconds.
What happens when the worst case scenario hits? How do you track unhandled exceptions that crash a request?
I never leave that to chance. I always set up a global exception handler. As shown on the screen, I use the built-in exception handling middleware or write a custom middleware class that wraps the entire HTTP request pipeline. If any unhandled exception bubbles up, this middleware catches it, uses the logger to log the exact stack trace as an error, and returns a friendly, sanitized 500 internal server error response to the user, so we don't leak sensitive code data to the browser.
In a microservices architecture, a single user click might travel through 5 different APIs. How do you trace a log across multiple services?
That is where correlation IDs become mandatory. When a request hits our very first API gateway, we generate a unique GUID, the correlation ID. We pass this ID in the HTTP headers to every subsequent microservice that is called. We configure Serilog to automatically attach this correlation ID to every single log entry. This way, when looking at our centralized dashboard, we can filter by that one ID and see the exact journey of that specific request across all 5 microservices in chronological order.
Logging is essentially writing to a disk or a network. How do you ensure that all this logging doesn't become a bottleneck and hurt application performance?
Performance is a major concern. As you can see in the checklist on the screen, we always use asynchronous logging so the main application thread isn't blocked waiting for a file to save. Second, we strictly avoid heavy logging inside tight loops. Third, we write logs to in-memory buffers first and flush them to external systems in batches. And most importantly, we set the minimum log level to warning or error in production, filtering out the verbose information logs that just waste disk space and CPU cycles.
Speaking of performance, .NET 6 introduced a feature called compile time logging source generators. Do you use those?
Yes, and it is a game changer for high-performance apps. Instead of calling the standard log methods, which require runtime memory allocation and boxing, you can define a partial method and decorate it with the LoggerMessage attribute, as shown here. The .NET compiler then automatically generates highly optimized, allocation-free logging code behind the scenes. If you are building an application where every millisecond counts, like a financial trading platform, this is the way to do it.
What about security? How do you ensure that sensitive data like passwords or credit card numbers don't accidentally get written into the logs?
Log masking is critical for compliance with laws like GDPR. We never log raw request payloads without sanitizing them first. I configure our logging pipeline to use destructuring policies or custom enrichers that automatically scan log properties. If it detects a property named password, credit card, or SSN, it replaces the value with asterisks or a masked string before it ever reaches the log file or database.
Here is a classic interview question. .NET provides ILogger, the generic ILogger, and ILoggerFactory. When should a developer use which?
In 95% of cases, you should inject the generic logger into your classes. The T is the class you are currently in. This automatically tags all logs from that class with the class name, making them easy to filter. You only use LoggerFactory if you are writing infrastructure code where you don't know the type at compile time and need to create a logger dynamically. And you rarely use the non-generic logger unless you are passing a logger down into a helper method that doesn't need its own category.
Imagine you have a production bug, but your logs are set to warning, so you can't see the detailed information logs. Do you have to restart the app to change the log level?
Not if you architected it correctly. You can configure .NET Core to reload logging configuration dynamically. If your log levels are read from the app settings.json file and you set reload on change to true, you can literally open the JSON file on the server, change the minimum level from warning to debug, save it, and the app will instantly start logging deeper details without ever dropping a user connection or restarting the process.
The industry is moving heavily toward OpenTelemetry. How does distributed tracing differ from traditional logging?
Logs tell you what happened, but traces tell you where the time was spent. Distributed tracing gives you a visual waterfall chart of a request. It shows you exactly how many milliseconds were spent in the API, how many in the database, and how many in a third-party service. Modern observability requires a combination of all three pillars on the screen: logs for events, metrics for numbers, and traces for performance bottlenecks.
Monitoring isn't just about reading logs. How do you actively know if your application or its database is actually healthy?
We use the ASP.NET Core Health Checks middleware. As shown on screen, I configure a specific endpoint, usually something like /health, and attach database checks to it. When our monitoring tool pings that endpoint, the app runs quick background checks, like attempting a lightweight query to SQL Server. If everything responds, it returns a 200 OK. If the database is unreachable, it returns a 503 service unavailable, which triggers an immediate alert to the engineering team.
That brings up a great point about alerts. Having logs is useless if nobody looks at them. What is your alerting strategy?
Alert fatigue is a real problem. If developers get an email for every minor warning, they will start ignoring them. We configure our monitoring dashboards to only trigger push notifications to our Microsoft Teams or Slack channels for critical errors, or if the error rate suddenly spikes by a certain percentage in a 5-minute window. Actionable alerts are the key to a fast response.
I sometimes see developers passing an event ID integer into their log methods. What is the purpose of that?
That is called semantic logging. Instead of just logging a string, you assign a specific integer ID to specific business events. As seen on screen, a successful user checkout might always be event ID 1001, and a failed payment is 1002. This allows external monitoring tools to group and track these events mathematically, making it much easier to generate reports and trigger alarms based on exact system events.
Logs can consume terabytes of storage very quickly. How do you manage storage costs in production?
We implement strict log retention policies. In our Serilog file sync, we set a file size limit and a retained file count limit so it automatically deletes logs older than 14 days. For cloud storage, we use lifecycle management rules to automatically archive older logs to cheaper cold storage after 30 days and permanently delete them after 90 days, depending on our legal compliance requirements.
This has been an incredibly insightful session. Finally, Arohi, what is the biggest mistake you see junior developers make when it comes to logging?
The biggest mistake is logging too much useless information and not logging enough context when an error actually happens. A junior developer might just log the phrase "order failed," but an experienced developer logs the order ID, the user ID, and the exact timeout response from the payment gateway. Always log the variables and the state that caused the failure, so you don't have to guess what went wrong when you read it the next morning.
Fantastic advice, Arohi. That was a detailed architect-level masterclass on logging and monitoring, one of the most critical parts of backend development. If this episode helped you understand how to protect and monitor your production apps, hit the like button, drop your questions in the comments below, and subscribe to the .NET Way. In episode 14, we'll explore unit testing versus integration testing in .NET Core and exactly when you should use which. Thanks for watching, and we'll see you in the next episode.